Hello, and welcome to this lecture. Imagine sitting on your couch with a pet dog or cat, or even just thinking about your own body. What do you and that furry pet have in common that a lizard or a frog completely lacks? Today, we are going to explore the incredible evolutionary inventions that define the class Mammalia and understand the biological and mathematical rules that make our existence possible. Let us start by looking at the most familiar traits of mammals. Why do these specific characteristics matter so much in the grand scheme of nature? First, female mammals possess mammary glands that produce highly nutritious, easily digestible milk, ensuring a much higher survival rate for their vulnerable babies. Second, all mammals have hair or fur at some stage in their lives, acting as a vital layer of insulation. Finally, mammals are endothermic, meaning they generate their own body heat internally rather than relying on the sun like reptiles do. This allows them to conquer almost every environment on Earth. Building on those core traits, mammals also possess highly advanced internal structures that give them a massive evolutionary advantage. The mammalian brain features a neocortex, which is the specific region responsible for higher order thinking, problem solving, and complex behaviors. If we look at the skeleton, mammals are uniquely defined by having exactly three middle ear bones, the malleus, incus, and stapes, which transmit sound with incredible precision. Additionally, they have a single, strong lower jawbone, known as the dentary, which supports their specialized feeding habits and allows for a much stronger bite force. Now that we understand their jaw structure, let us look at what is inside that jaw. Mammals typically have different types of teeth, such as incisors, canines, premolars, and molars. This condition is known biologically as heterodont dentition. Because mammals are warm-blooded, they require a massive amount of fuel to survive. These specialized teeth allow them to mechanically break down different types of food efficiently, extracting the maximum possible energy required to maintain their high-energy, warm-blooded bodies. Without these specialized teeth, mammals could not sustain their active lifestyles. This constant need for energy brings us to a critical biological challenge. To truly understand the cost of being a warm-blooded mammal, we have to look at how much energy they consume on a daily basis. Because mammals generate their own heat, their basal metabolic rate, which is the absolute minimum energy they burn just to stay alive, is much higher than that of cold-blooded reptiles. But how exactly does this energy requirement change as a mammal gets larger? Does an elephant need proportionally more food than a mouse? This is where mathematics steps in to explain biology. To answer that question, biologists use a famous mathematical equation called Kleiber's law. Conceptually, it shows that as a mammal gets larger, its energy needs increase, but not at a simple 1-to-1 ratio. In this formula, B represents the basal metabolic rate. B0 is a biological constant, depending on the animal group. M is the body mass in kilograms. The most important part is the exponent, 0.75. Because this is less than 1, it means a larger mammal is actually more energy efficient per kilogram than a smaller one. If mass increases, total energy increases, but at a slowing rate. Let us see this formula in action with a concrete example. Suppose we want to find the basal metabolic rate of a medium-sized dog. We are given a mass of 16 kilograms and a constant of 70. We substitute these into Kleiber's law. To handle the exponent 0.75, we rewrite it as the fraction 3/4. The denominator tells us to take the fourth root of 16, which is 2. The numerator tells us to cube that result, giving us a scaling factor of 8. Finally, we multiply 70 by 8. The dog requires exactly 560 kilograms per day just to stay alive. Now that we have calculated the energy a mammal needs, let us return to how they process the food to get that energy. Zoologists use a mathematical shorthand called a dental formula to classify different mammals. This formula acts as a precise map for the mouth of the animal. It represents the exact number of incisors, canines, premolars, and molars on just one half of the face. The top numbers represent the upper jaw half, and the bottom numbers represent the lower jaw half. Let us look at the specific formula for humans to see how this works. Here is the standard dental formula for a healthy human adult. Conceptually, it breaks down our heterodont dentition into 4 specific tooth types. The letter I stands for incisors, C for canines, P for premolars, and M for molars. For each letter, the fraction shows the count for the top half jaw over the bottom half jaw. For example, we have 2 incisors on the top half and 2 on the bottom half. If any of these numbers were to increase or decrease, it would indicate a missing tooth, a mutation, or a completely different species of mammal entirely. Let us use this formula to calculate the total number of teeth in a human mouth. We are given the counts for one half of the face. First, we add up all the teeth on that one side. The upper half jaw has 2 incisors, 1 canine, 2 premolars, and 3 molars, totaling 8 teeth. The lower half jaw also totals 8 teeth. Adding these gives us 16 teeth for one entire side of the mouth. Because the formula only describes one half of the face, we must multiply this result by 2. This gives us a final total of 32 teeth. To bring all these concepts together, let us look at this detailed biological diagram. On the left, you are seeing a cross-section of mammalian skin. Notice the hair follicle providing insulation and the mammary gland which produces milk. On the right, we have a mammalian skull. Look at the jaw. You can clearly see the heterodont dentition with different shapes of teeth adapted for processing food. Finally, the zoomed-in circular inset reveals the 3 tiny middle ear ossicles, the malleus, incus, and stapes. This single image beautifully captures the defining physical traits of our class. We have covered a lot of ground today, so let us summarize the most important ideas. First, remember that mammals are uniquely defined by their ability to produce milk, grow hair, and maintain a warm body temperature. Second, these physical traits are supported by advanced skeletal features, like the 3 middle ear bones and specialized teeth for efficient feeding. Finally, we saw how mathematics governs biology, from using Kleiber's law to calculate energy efficiency to using dental formulas to classify species. You now have a solid understanding of what makes a mammal a mammal.